So good afternoon, everybody, and welcome to this first conference of the Coast, Ports and Sea thematic section of the 2020 digital edition of REMTech. My name is Michela Soldati from Ravenna Municipality, and for this conference I will be the chairwoman today. This conference has been organized in the framework of the Asteris project, which is a project funded by the Interreg Italy-Croatia program, and it's focused on adaptation to saltwater intrusion in sea level rise scenarios. So today we will talk about climate change, adaptation and resilience planning strategies, as the title of the conference says, looking in particular to coastal areas and therefore looking to the factors that increase the vulnerability and the risks in coastal area and how to take into account of them in urban planning. Before starting, I'll give you some practical information. So as you may be already aware and used to this kind of platform, your microphones and webcams are switched off. We are recording the webinar so that it will be available on our platform then in the next days on REMTech website. And in particular, it will be available on our exhibition room called Asteris. Please write your question in the chat so that at the end of the presentation, we will have a dedicated section to answer to all the questions. Before starting, I'd like to give the floor for a greeting to Andrea Damariolo, who is the coordinator of the scientific board of the Coast, Ports and Sea thematic section of REMTech. So Andrea, please, the floor is to you.
Thank you, Michela. Thank you. Well, good morning. I'll share you only, my presentation is only about cost. And okay. So you can see the website of COST. Okay. Good morning. I'm Andrea Zamariolo, the coordinator of COST, the focus of REMTech dedicated to the sea and ports. I'd like only to spend a few words to thank all of you to be here today. We are at the beginning of our REMTech week with this new digital platform, so we are pioneers, a kind of modern pioneers. I'd like also to thank Michela Soldati for the organization of the technical meeting about a very important theme. In particular, I believe that adaptation will be a key word in our next future. Here in Emilia-Romagna, in Italy, but also in many places in the world, important places, very populated places. So I think it is very important we talk about adaptation. So let's start with our meeting. I wish you good work by all the REMTech staff. Thank you, Michela.
Thank you very much. Okay, if you can, okay, and thank you very much, Andrea. So let's start with our conference, and the first, well, two presentations will be, sorry, is there someone that we have that has the microphone on? Please, all the co-hosts, keep your microphone off. Sorry, I'll start again. So the first two presentations of today, we have a slight small change in the program. Will be more focused on the activities that are carried out by the partnership of Asteris project. So we will start describing the vulnerability and risk analysis and monitoring of and hydrological modeling concerning the impact of sea level rise on Adriatic coastal aquifers in the Italian side. Unfortunately, we just got to know that our speakers from Croatia had a problem, an issue, so she cannot join us. Nevertheless, of course, we will just jump her presentation. I'll share you very quickly just a second, the program. So then we will go on focusing the attention to the future sea level rise scenarios for the North Adriatic Basin, which is the main driver for the vulnerability along the coast. And at the end, we will have a presentation about adaptation strategies with the important experience from Cervia municipality that, thanks also to the Adriatic Interreg project, already included the adaptation scenarios and action at different planning levels. So I'll give the floor to start to Simone Galeotti from Urbino University, which is the coordinator of our Asteris project for the first presentation. Please, Simone.
Okay, thank you, Michela, and thanks to the organizers for this occasion to present the project. While I'm trying to share here, I hope you can see the presentation now on my screen, which is shared now. So as Michela anticipated, this is about Asteris, which is the acronym for a project that is called Adaptation to Saltwater Intrusion in Sea Level Rise Scenarios. And I'm basically skipping this part because Michela has already anticipated. This is within the umbrella of the Italy-Croatia program, following a call for standard project that has been activated in 2017. Now, this is a summary of the actors, the partners involved. There is the University of Urbino, there is the CNR, Italian CNR, and then there is also territorial agencies and a governor of the territory, like the municipality of Fano, the municipality of Ravenna. There is Metrist Research Center from Croatia. There is the Institute for Adriatic Crops and Karst Reclamation, again for Croatia, and Croatian waters. So it is a mix of Italian and Croatian partners that are dealing both with the scientific and technical aspects and the aspect of land management and policies in the land management. Now, what is this about? It is about this object here, which is the Saline Wedge. And we need to first know that coastal aquifers are actually characterized by a gradient, which is a natural characteristic of the system, towards the seaboard, where groundwater discharges into the sea. And in this setting, usually and normally, a saline wedge exists below the lighter fresh water. So the point here is to first understand how this works and what is actually regulating the saline wedge. And this is regulated by, say, natural control factors, which are related to the hydrogeological setting. Then it's controlled by sea level. It is controlled by precipitation, that is to say that the amount of water that is coming from inland. And of course, there is an anthropic influence on that regulates also the possible intrusion of the saline wedge, as you can see on the lower panel, where you have a cone of depression that is forming just because you're pumping fresh water out of the water table, the fresh water table. Now, the problem is that salt wedge ingression can have multiple impacts on the coastal aquifer system, and potentially is affecting adversely the environment and the economy, thus society, putting at risk the quality and the availability of drinkable water, the availability of water for agricultural use, and also there is an impact of the water chemistry changes on buried infrastructure along the coast when it's getting in contact with salt-rich water. I hear a voice. Can I ask everybody to I don't know. Well, so the reason to keep on to run this project is summarized in these slides. The Adriatic region is highly vulnerable to the adverse impact of climate change, primarily for a reason, because in the global context of the expected climate change and future scenarios, the entire Mediterranean region can be seen as a hotspot of change in terms of both temperature changes and in terms of precipitation, which, as we saw before, is one of the factor controlling aquifers, of course. Now, facing this problem, there is a need to gain a common risk assessment for the Adriatic community. And so one of the goals of the project of Asteris is to gain and to go towards a common risk assessment between in the two coastal areas that are facing the sea. And of course, we are focusing particularly on aquifers that are already characterized or particularly vulnerable to salt water ingression. This is done in work packages. This is summarized here. And I am focusing more on this work package number 3, also considering that there will be a presentation mainly focusing on WP4 later on by the colleagues from the CNR of Pisa. And so this is about modeling present and future salt ingression in Adriatic coastal aquifers. Now let me start by saying that we can see these in terms of impact of climate change in general, but we have to see this on a regional scale. And then again, because we are dealing also at the end of the idea of the project is also to provide people working on land management with suggestions and ideas on how to prevent the risk. We need to have an idea of specific impacts on coastal aquifers at the local scale. Now this presents a problem because, as I was saying before, sea level is a problem. Of course, the hydrological setting is a problem, and precipitation is also a problem. Now, as far as hydrological setting is concerned, what we have done, and I'm now presenting some of the results that we have obtained, is to try to design a map of territorial hazards to salt ingression for the entire area that it's under consideration. So this is basically the central and the northern Adriatic. And the map is constructed in a way that considers both natural factors and man-driven factors. So this is the concept of vulnerability in this case is subtending and comprises the aquifer's susceptibility in itself, which has to do with the topography, the hydrogeology, the intrinsic characteristics in terms of geology, and so forth, but also the hazard streets, which has to deal with human pressure and in the future with sea level pressure. This is the result of what we have been calculating and computing and doing. We have obtained 3 maps with different classes of vulnerability and hazards. And the 3 different maps are calculated based on the elements and control factors that was mentioned before, considering different weights for the different individual factors that we have considered. Now, the idea is to consider this middle panel here, basically because there is not much deviation by considering different weights, and because, of course, the median, this is the middle case, so it's the one that is less affected in theory, statistically speaking, by errors. So first result, we have obtained a map of classes of territorial hazards for coastal aquifers for the entire region. And now we have to do with these 2 factors, changes in precipitation and changes in sea level for future scenarios, because we want to know what is going on in the future. And particularly, the projection that we are using are set at the end of the century as a longer term simulation of future scenarios. Now, what is included in these slides is, let's say, a global perspective of temperature and sea level changes over the next century. I mean, till the end of the century. As you can see, you can consider different scenarios, which are here summarized as RCP, and this is referring to different scenarios in terms of carbon emission for the time interval between here and the end of the century. What we are focusing on is this RCP 8.5, which is business as usual, and this is the results. These are models that are published by within the fifth report of the IPCC in terms of global changes in temperature and in terms of global changes in precipitation. Now, on the left side of the slide, you have the result in terms of sea level change. Again, comparing RCP 2.6 and RCP 8.5. Now, the problem is that when you're dealing with these models, these are actually giving you a global perspective, but we want to know what is happening in a more precise way within this area. And so to do that, we have run a series of simulation, considering as boundary conditions those depicted by RCP 8.5 of IPCC. And we have projected this for the time interval 2070, 2100, sorry. And so what you can do is to compare this in terms of difference, for instance, of minimum temperature, maximum temperature, precipitation, consecutive dry days, and ensemble mean in terms of precipitation in the future for these 30 years that are considered by the model. And I want to thank here people collaborating also from institution external, not directly connected to the Asteris project, which is the ISAC CNR Institute in Turin. And so this is the summary of the climate scenarios. On this basis, we will have to run a simulation of what is going on to the risk, to the hazard, to saline water ingression in the considered coastal system based on what we saw before. So the general characteristic of the area in terms of coastal aquifer. What you see on the left, on the right, is again a prediction, and it's a numerical simulation, but now we are dealing with sea level. What is there is, in terms of centimeters, what is the expected sea level rise from here to year 2100 again. As you see, there are relevant deviation, well, maybe not so relevant, but there are deviation from the eostatic curve, which means that not all the areas, of the central and northern Adriatic are suffering from exactly the same sea level rise. So there is a deviation which is important to consider, as there is a deviation in terms of changes in precipitation. So this is giving us a picture of what is going on a regional scale. What is also important to consider is that we will need to have a local approach, as I mentioned before, because we ultimately want to give suggestions and idea for land management, which are practical suggestions. And now we need also a local approach. And the local approach is dealing with the understanding of the influences of the sea level rise and temperature changes, and thus precipitation changes in the area, because as I mentioned before, they are not uniform and they depend on a complex array of factors for each site. Now, the local approach is also used for calibration, because we do have 3 case studies in the area that we are considering, which is again represented by this yellow polygon here. Basically, again, it is the central and the northern Adriatic. To calibrate the results of the modeling, we have 3 case studies. One is along the Ravenna coastal area. The second one is along the Fano coastal area in the province of Pesaro Urbino. And the third one is in the Neretva Delta area, which is the presentation that we are actually missing by Monica Zovko later on. This is done independently by the Italian partners and the Croatian partners, but following and really sticking to the philosophy of the program, there is continual dialogue, a confrontation to gain finally because one of the final goal is to gain a common strategy for risk assessment and for solving problems related to future climate changes in the area in terms of saline ingression. So to summarize, the project approach, it's been the assessment of the vulnerability, which has already been done, to derive future scenarios of sea level rise and climate, particularly in terms of precipitation, which has already been done. And this is the results that I've been showing you. And then on this basis to define a characterization from both the hydrological and geochemical point of view of the selected case studies, which is the subject of the presentation that are given by the colleagues in Pisa later on in the program, which is very much useful to form a basis for the characterization of the coastal system within the municipalities that we are considering as case studies, but it is also vital and crucial for the calibration of the modeling that we are running. Now, this is basically aimed at implementing application-oriented actions in collaboration between the scientific component that I'm talking about and the municipalities and the territorial agencies that are distributed in the area. So this is a summary of it is the summary of the overall objective. Now my computer is saying me that it is 3 o'clock. So I think I have to stop here. I leave you with this slide that you can read yourself, but it's basically a repetition of what I have already been mentioning before during the presentation. And most of all, I really want to thank you, everybody, for your attention. Thank you.
Thanks to Simone Galeotti for his presentation and to be very sharp. And so now we give the floor to Barbara Misi from the National Research Council, Institute of Geosciences and Earth Resources, that we talk us about hydrological survey and aquifer seawater intrusion modeling, the first results from Ravenna's and Fano's coastal areas. The floor to you, Barbara. Thank you.
Okay. Thank you, Simone. Thank you, Michela. So in this talk are here presented the first results and critical issues for 2 case studies, Fano and Ravenna coastal area involved. The specific targets are focused on improving the conceptual models for Ravenna and Fano coastal systems to provide an update on the salt water distribution in these aquifers, to understand the intrusion mechanism and develop and transport a numerical model for the coastal aquifer system of Fano. Different scenarios of marine intrusion will be considered, also taking into account a simulation of future sea level variation. Fano and Ravenna coastal system are 2 shallow phreatic aquifers which have been selected to evaluate the risk of salt ingression in freshwater aquifers due to their specific hydrological conditions. For Fano, the selected coastal area is representative of the aquifer system hosted in a recent alluvial deposit above the impermeable substratum at the depth between 6 and 45 meters. For Ravenna coastal area, the study site was selected on the basis of previous works and related to the shallow groundwater aquifer. The sampling strategy involved piezometers, well and surface waters, where in situ measurements, pH, temperature, electroconductivity, water level, and vertical physical chemical logs were performed. At each sampling, 4 aliquots for chemical and isotopic analysis of water were collected. By monitoring point of view, to date, 2 surveys were carried out at Fano Ravenna for water sampling and physical chemical parameters, then 5 surveys for water level and physical chemical parameters at Fano, and finally 4 surveys for piezometric and physical chemical parameters along 2 main transects orthogonal to the coastal line at Ravenna. Moreover, 3 multi-parameter probes and 1 barothermometer were installed at Fano in order to perform a continuous monitoring of water level, temperature, and electroconductivity. At Ravenna, the piezometer vertical profiles evidenced the strong chemical stratification. As we can see, the log measurements show that an abrupt increase of the electrical conductivity at shallow depth occurred. After purging, some wells were still maintained the water stratification, whereas in other cases, the fresh water recovered for a while as the seawater was displaced. In this case, from each stratification were collected for chemical and isotopic analysis. In this slide, the piezometric levels and the vertical profiles of electrical conductivity along the Ravenna transect are reported from where a marked seasonal variability was evidenced. For instance, hydrometric and piezometric level up to more or less 1 meter, and for the electrical conductivity up to 45,000 microsiemens. Moreover, it seems that the Lamone River is playing a key role in transferring seawater into the aquifer. As recorded, the Fano aquifer system was selected for numerical modeling due to the apparently lack of significant seawater intrusion, which can then be used for a comparison with that of Ravenna, where the shallow aquifer is already spoiled by the Saline Wedge. Practically, we have the possibility to simulate how the Fano aquifer may evolve should the seawater enters the groundwater system. As you can see, from June 2019 to September 2020, no significant changes in the isophreatic distribution were observed. The Fano aquifer being mainly fed by the meteoric waters infiltrating from the reliefs of the Apennines and the Metauro River waters. So the peculiar and different hydrogeological setting of the Ravenna and Fano coastal areas allow to discuss together the geochemical characterization and related modeling. The main chemical components dissolved in the waters can be summarized by cations and anions triangular diagram. The Fano waters mainly consist of calcium and bicarbonate, whereas those of Ravenna show increasing proportion of sodium and chloride. This implies that the geochemical phases were varying from bicarbonate calcium, typical of surface and shallow waters, to sodium chloride. The oxygen and hydrogen isotope ratio measured in the Ravenna waters display a large isotopic variation and are distributed along the global and central Italy meteoric waterline, pointing to a meteoric origin, indicating a significant and increasing mixing with the seawater. It is to remark that the previously recorded stratification in the piezometers waters of Ravenna is confirmed by the water isotopes. The deeper water being much heavier, approaching to seawater composition than those at a shallow level. Differently, the isotope ratio of the fan waters are included in a relatively narrow range and straddle the global and central Italy meteoric waterline. They also have a much more negative isotope signature with respect to those of Ravenna. Accordingly, the presence of seawater in the Fano aquifer can presently be regarded as negligible. The hydrogen and oxygen isotope ratio versus chloride diagram, as we can see, confirm that Ravenna waters are affected by mixing with the seawater, whereas those of Fano divert significantly from this trend, suggesting that up to now, the saline intrusion is practically absent. This means that isotope ratios of fan waters can be useful in order to trace their source, suggesting a meteoric water origin that infiltrating in a recharge area ranging between 80–300 meters in altitude, which is corresponding to the average values of the reliefs of the survey areas. The isotope difference between the two aquifers are further supported by the main water chemistry. A clear positive correlation between sodium, magnesium, potassium, and calcium versus chloride is observed where the fan waters are clustered at the lowest concentrations, whereas those of Ravenna show a much wider range. Consequently, the distribution of the Ravenna waters can be modeled to quantify the amount of seawater in each site. The theoretical black and the red line represent the mixing between sea and fresh water computed by using low salinity water sample, at which an increasing amount of seawater for Fan Ravenna waters was added. The Ravenna waters distribute along the geochemical modeling best fitting, indicating that the seawater contribution is between 10 to 18%. On the contrary, the Fan waters do not appear to be affected by seawater intrusion. It is to remark that the geochemical modeling is better applied when conservative solutes such as chloride, magnesium, and partially potassium are considered. So the chemical composition of shallow water does not necessarily reflect an ambiguously natural geochemical processes. For example, total dissolved solid variations in water are the result of combined effects, for instance, lithology, pollution, and so on. As a consequence, TDS is plotted against the bicarbonate nitrates and sodium calcium ratio, considering nitrates as a member related to anthropogenic source, while bicarbonate and calcium are representative of weathering processes, and sodium representative of the saline wedge. So the data distribution in such diagrams indicate that the FANO waters are influenced by interaction with the nitrate-rich component, likely due to agricultural practice, whereas more extreme sodium-calcium ratios of the Ravenna water once again are due to the interaction with the seawater. So concluding, two main remarks. The first, as evidenced by the hydrogeological investigation, the geochemical modeling, the Ravenna aquifer is already affected by significant contribution of seawater, whereas that of Fano is still apparently dominated by fresh waters fed by the Apennine chain and Metauro River. And as a consequence, the Fano and Ravenna aquifers are thus represented two important members for modeling and simulating different scenarios related to possible future climate change, and eventually export these results to other areas of the Adriatic Sea. That's all. Thank you very much for your attention.
Thank you very much. Okay, thank you very much to Barbara for this presentation focused on this specific aspect of the monitoring and analysis of the effect of the sea level rise into the saltwater intrusion. Now we can go on talking about the future scenarios of the sea level rise in locally applied to the North Adriatic Sea. And so I give the floor to Luisa Perini from Emilia-Romagna region, and the floor is to you.
Thank you. I try to share the screen. So, well, can you see properly the presentation?
Yes, Luisa.
Perfect. Thank you.
So my speech doesn't deal exactly with the topic of the meeting, but I think anyway it can give information useful for the knowledge framework, especially in the Ravenna area. So I'm going to talk about, briefly go through an introduction of the Emilia-Romagna coastal zone, its features and present risk. Few words on the coastal evolution under past climate changes, and then possible increase of coastal risk due to sea level rise. Well, as everybody knows, the Emilia-Romagna coastal zone is a very important area to all the regional economy. Indeed, here with the 130 kilometers of a coastline mainly represented by sandy beaches, we host one of the most important tourist attractions in Europe. And also in the northern part of the region, we have very important natural areas. Indeed, there is the Manan Biosphere Reserve declared by UNESCO. But besides the tourism, we also have important assets, other important assets such as aquaculture, fishery, and at sea, the oil and gas industry. but the coastal area is very sensitive to climate change, is a very vulnerable area, mainly because of its geomorphological setting. Indeed, here we have large areas below mean sea level. You can see here in the picture in blue, they are represented, and they are almost in contact with the sea because they are the only barrier is represented by the beach system, beach and dune system. And this geomorphological setting combined with the effect of natural and anthropogenic subsidence can increase the level of risk. So it's very, very important to monitor erosion of coastal dunes that are still present only in the 30% of the coastline, beach erosion, seabed lowering, and the impact of sea flooding. All these processes are a factor of risk that coastal risk is emphasized due to the high urbanization of the coastal area. Indeed, we have, if we consider a coastal strip wide around 1.5 kilometers from the shoreline, we have calculated that after the Second World War, we have had an urban sprawl of around 400%. And looking at the recent monitoring, we can see that the beach erosion still affects around the 40% of the shoreline, but we are able to reduce this factor of risk thanks to intensive nourishment. And in the last monitoring, we observed that then, thanks to this intervention, we are able to reduce the beach erosion to an 18%, thanks to this intervention. And besides, it's very important to monitor the dune erosion because somewhere in some along some transect of the coast, we have calculated retreating of the coastal dune, the active coastal dunes, up to 1 meter per year. And this can increase a lot the risk of coastal flooding. So very, very important are the interventions, such as the big nourishment intervention that we have carried out 3 times at the moment, using the sand that we have discovered on the seafloor offshore the Emilia-Romagna coastline, and that are related to ancient coastal deposits that were laid on the seafloor during the last transgressive phase after the last ice age period. What about the coastal flooding? Coastal flooding have been the areas at risk of flooding have been mapped according to the flood directive. And we can see that at the moment, the areas at risk of flooding are having a surface of around 78 square kilometers, 22 of them insisting in urban zone. So for all these reasons, it's very, very important to deepen knowledge on the past and future scenarios of climate change. From the past, indeed, we can learn a lot in order to better manage the future. About the past, we can have very important information from the geological setting of the coast. Indeed, thanks to the reconstruction of the geological sequence of the coastal plain that was done through survey and corings that allowed us to define the different features that represents the past coastal deposits, we could map the ancient shoreline that 6,000 years before present was at a distance of 23 kilometers in the Ravenna area, up to 42 kilometers from the present shorelines in correspondence of the Delta Po. And so, it was this ancient shoreline correspond to the maximum transgression phase that followed the last glacial period. Then, starting from that period, an important progradational phase occurred, and the rivers were able to construct the present coastal plain and up to the maximum shoreline that corresponds to the present one. It's important to underline that the last little ice age that was dated 1,300 to 1,085, so around 170 years before present. It was the phase in which the maximum advancement of the river mouth occurred. And it's very, very important to underline this, because it was the last period in which the beach, as we know today, were created. This accretion phase so ended at the end of the 18th century, and after that we assist to a coastline rectification process that brought to the dismantling of the river mouth. And so in correspondence of them, we monitor the maximum retreating of the shoreline. What about the future? We tried to analyze the potential impact of the sea level rise, projecting them to the 2100. We have done this work in cooperation with the University of Urbino, the Professor Giorgio Spada, and with the Institute, the National Institute of Geophysical and Volcanology. And we have modeled, using GIS and GIS approach, the combined effect of subsidence and of sea level rise. And we have analyzed the increase of potentially floodable areas to 2100 in correspondence of a system event with a return period of 100 years. That is the P2 scenario according to the flood directive. So we have created a digital terrain model projected to 2100 by combining the present digital terrain model and a digital velocity model, that is the subsidence, the present subsidence projected to 2100. This model has been used as base of Rationale to run our model for flooding, And as a scenario, we have considered a scenario of a sea storm combined with a best scenarios of sea level rise that correspond to the RSVP 2.6. And a second scenario that was considered was a sea storm event, a P2 sea storm event combined with the sea level rise worst scenarios, that is the RSP 8.5. The limit of our modeling is that we have not considered the hypothesis of new intervention during these 85 years. And as a geomorphological evolution was considered as only the subsidence rates. And we have not projected other kind of morphodynamic evolution that, of course, could be considered during this time. So going to the example of cartography, we can see some example of the difference of the floodable areas that according to the flood directive map, and the increasing of these floodable areas, only considering the subsidence factor, considering that is in purple, considering in fuchsia, I missed the word. In blue, you can see the increasing of floodable areas, considering subsidence and sea level rise in the best condition, and in purple you can see the further increase due to sea level scenarios in worst condition. So going to the final results, what we have calculated is that the maximum increase in flood risk is expected in the central part of the region, that is the Ravenna and Cesenatico provinces. This is due to the large extension of areas below sea level, and to the absence of elements that can really contrast the sea ingression. We have calculated that only due to the subsidence impact, the floodable areas can increase 2 times if compared to the today's situation. And if we consider the subsidence plus the worst scenarios, the floodable surface could increase 3 times. So it's very, very big, the level of risk that we can encounter up to 2100. So finally, we have to consider that these maps have some limits, but beside that, we can now we are able, thanks to this analysis and to this map, we are able to define more critical stretches where address punctual monitoring and appropriate mitigation measure in order to contrast the effects of climate change in terms of floodable areas. So I have concluded. I thank you a lot, the organization and everybody for the attention.
Okay. Thank you very much to Luisa Perini, that actually gave us a very important overview of a crucial factor of the climate change in coastal area, which is the future sea level rise scenarios that will actually affect vulnerability and risks of the coastal area, as she showed us. In fact, to be able to assess the future vulnerability and risk in coastal areas is actually of crucial importance when we go to planning the management of coastal areas, and mainly when we come to urban planning. So I give now the word to Daniele Capitani from Municipality of Cervia. He is the head of Planning and Territory Management Division, and he will talk us about their experience in actually transferring this concept into planning. Thank you very much to Daniele Capitano.
Good afternoon. Thank you for the organization. Start the presentation. Resident territorial planning, the experience of Serbia. Serbia dates to remember Municipal Council Resolution number 18, signing of the Covenant of Mayor by Serbia Municipality. Municipal Council Resolution number 73, approval the Sustainable Energy and Climate Action Plan, is the second SECAP in Emilia-Romagna region. Municipal Council Resolution number 70, approval of the PUG, General Urban Plan, according to the Regional Law 24/2017. This is the first PUG in Emilia-Romagna region. And then 10 July 2019, waters put devasted a huge part of Milano Marittima Pinewood and created a big damages also to the economic system. The Municipal Council Resolution number 39 declared the climate emergency. From here, we felt the need for a new value platform. The most important aspects are soil protection, raising urban quality, and attention to the various risks. For soil protection is important reduction soil consumption, increase soil permeability, increase soil fertility. The most important for Cervia raising urban quality is ecological networks and ecosystemic services, and the urban mobility qualification towards a sustainable model. And then attention to the various risks, attention to seismic risk, to climate change, mitigation, adaptation, climate-proof city, and a new sensitivity in urban transformation about where to orient this sensitivity. The goal is to create a resilient and anti-fragile territory. Resilience is a resilient city in a urban system which react adapting to the current change, example global warming, and incorporating them to recover after huge upwaves, earthquakes, floods, storm, etc. Anti-fragile territory and anti-fragile city is a system which can strengthen, improve, and also develop thanks to catastrophe, disturbances, stresses, and volatility. So we have a new model city, resilient and anti-fragile cities. The vision focuses of Cervia construction in our PUG as a resilient city, giving a good representation in a four-dimensional space consisting of the following scenario: Serbia identity city, Serbia safe and friendly city, Serbia green city, and Serbia accessible city. The main focuses are increased urban quality, decrease soil consumption, also thanks to the reduction of building areas, promotion of urban regeneration and recovery of the existent, urban green, reconnected and ecological network integration, strengthening of public and private ecological facilities, risk reduction measure, seismic, hydraulic, climate change impacts, and risk reduction intervention and climate change adaptation mitigation measure are included in interior documents. The most obvious difference between the two plans, old PRG and the new PUG, is represented by PRG, city expansion and conforming plan. PUG, urban generation, strategic plan. And it's very important, minus 58% soil consumption compared to PRG. The central element of the new territorial planning, according to the regional law number 24/2017, is the strategies. Her name is SQUARE, urban quality and ecological environmental strategy. And the general goals, territorial equipments, infrastructures, and public utilities, reduction of pressure and settlement system on the environment. In this slide, we see the new urban park, 400 acres, cycleways master plan, cycleways route, marine aggressions defense, green connection, green screening is the most important ecological elements of the plan. Another way to represent the strategy is the matrix, is the fish. The action pertinent to today's discussions of the urban system have been highlighted in this in the fish, and the most important element is the implementation of the SECAP. Two other scenarios, Serve accessible city and Serve entry city, and we see the star, the action will increase anti-fragility, strictly connected with the ecosystem services and climate change are marked with the star. And then we have the Covenant of Maryland, the SECAP, Municipal Council Resolution number 18 and number 73 approved the SECAP, the second SECAP in Emilia-Romagna region, aimed at reinforcing adaptation capability and guarantee citizens the access to safe, sustainable, and available energy, producing local energy from renewable sources. Speed up the decarbonization, helping to keep medium global warming under 2 degrees. And the goal, reduction of 40% of total emission within 2030. It means 18,000 tons of carbon dioxide. Some mitigation adaptation action have been identified to reach the objective set. And this mitigation action, 13 more have been undertaken, and for adaptation action, 4 more have been undertaken. This is one of the most relevant action of SECAP adaptation action concerning climate change, permeability of the ground. For we is very important, in line with this fish of the plan, the following action have been introduced and enhanced in the PUG: reduction of expansion areas, increase of permeable surface area, discipline and protection of green and agricultural areas also within the urbanized territory, improvement of rainwater drainage surface, and then construction of large rolling bases to service the town of Pinerella and Tagliata, about 7,000 cubic meters. This is the plan of Pinerella rolling basins. Here is another very important action of the strategy: increase the coastal resilience and face the problem of marine ingression. In according to this fish of the plan, thanks to project Interreg Italy-Croatia Adapt, Serbia started to climate change monitoring activity through survey of impact of urban island, flood, sea level rise, and marine ingression, salt intrusion, vulnerability assessment, firework requirement. For the mesoclimate and the microclimate, important is put in the territory 6 temporary weather stations that detecting temperature and relative humidity, and 1 permanent weather station detecting temperature, relative humidity, wind speed, wind direction, pressure, rainfalls, sun radiation. What to expect from this analysis? Spatial representatives of urban Thailand related to the measurement period, guidelines allowing the administration to continue monitoring erecting with appropriate protective measure, in-depth analysis of data collected, tropical nights, intensity of distribution, days with its stress, annual variation of urban Thailand. Microclimate value calculated every second with this the instrument calculates in every second all of this value: air temperature, humidity, vertical profile of temperature, thermal turbulence, wind speed and direction, noise level, radiant temperature, air quality, geolocalization via GPS sensor, solar radiation. Two hemispherical chambers filming continuously, coupling each measure to the place instant itself of the measure. It's possible to investigate the effect on the floor or the side coverings, the vegetation impact, the effectiveness of shading device. The results obtained offer valuable guidance for researching a point-oriented solution for the citizen welfare. It's a very important point for the municipality, since green is a focus of the new planning strategy, and it's also one of the reasons why Cervi is a famous tourist destination. These are the microclimate detention path. Longitudinal path is parallel to the coast. The salt pan city center path, and the third pinewood path through the pinewood. Microclimate details analysis of each path, comparison of the collect data with the urban characteristics, hotspot and cool spots, identification, maps of the main parameters for each route are temperature and absolute humidity, wind, physiological equivalent temperature, mean radiant temperature, noise intensity, and air quality. Particular points of interest are documented through data sheets containing physical data and image. Another action which is studied in the Adaptation project is the marine ingression defense. Proposal for action to increase coastal resilience and marine ingression, balancing the system of the coast section through the reconstruction of the zone, a very important component of the dynamic land-sea transition system, symbol of resilience and element of natural defense against erosion, marine ingression, and salinization of groundwater. Pilot project, area facing the Varese colony subject to erosion, main point of marine ingression is stormwater, and only point in the northern part of Serbia's coast where part of the natural dune has been maintained. The final goal is very ambitious overall, that moves to the current shoreline to see and bring the existing establishment into the location and retrodonal area with the complete reconstruction of the dune cordon along the entire coast. Salt intrusion monitoring, thanks to the project Interreg Italy, Croatia, Adapt, collection of Saline Wedge data, knowing the entity of the salt intrusion with a view to a future requalification of the natural park to properly select 3 species for a new planting. And we are appropriate to replace or supplement the species of pine currently present. We installed a piezometer and we are doing a measurement campaign, piezometer installation, measurement. And what we'll do rain floods, mapping urban areas, typical depression subject to the accumulation of water by intense meteoric events, with consequent episode of flooding. So characterization of intense historical rain events and their evolution in a climate change scenario, modeling and simulation, flood mapping under different rain intensity scenario, current state, condition of climate change, urban planning, assessment of expected economic damage, data sheets contain physical data and image. But is important action, and so from word to action. The issue of security covered the entire territory and required the collaboration of public and private to be put in the foreground, ensuring solidity and resilience to the city through redevelopment and urban regeneration. For example, the in-depth study of hydraulic risk focused on the design of the public city and found confirmation is the redevelopment of Milano Marittimo waterfront, Milano Matteotti, and Borgo Marina, urban regeneration, where urban furniture and the adoption of nature-based solutions act as safety measure against flood, combining the aesthetic component with the functional one. Private city has the goal to intervene for the safety of its component. Conclusion, today the last generation of town planning adhere to the principle of European Green New Deal and then assume among non-negotiable invariants mitigation, climate adaptation, declare to adhere to the concept of resilience and anti-fragility, become the subject of a plurality of experts from different fields on scientific research. Cervia adhere to the principle above already long ago, well before the calamitous event of events of 10 July 2019, opening the through of the substance. Next step for this administration, SECAP update December 2021. Since the implementation of the adaptation measure planned in the SECAP constitutes the backbone of the PUC strategy, and with the latter are consistent, the result is in fact an update of territorial planning in order to complete the triad of the territorial planning of the last generation of municipal levels. It falls within the objectives and of the administration, the planning and approval of the SAMPs, even if not doable by law for a small municipality like Cervia. Thanks for your attention. Good afternoon.
Thank you very much to you for this very interesting presentation. And yeah, can I go on? Yes. That was the last one, and it was very interesting because Daniele Capitani showed us how complex can be the planning of the adaptation strategies to climate change. In fact, the actions can be included at different levels of planning, and they can interact with each other in order to face multiple risks. We saw that when we come from analysis of the vulnerability, as we saw at the beginning, analysis and monitoring analysis, that take into account all the factors that derive from the climate change and the drivers that the climate change put into vulnerability and risks. Then when we go to planning, we saw that we can integrate specific plans, such as the very important Sustainable Energy and Climate Action Plan, that is specifically focused on increasing the adaptation and the resilience to climate change, to more traditional urban plans, if we can say so, but actually that they can have a traditional approach anymore. They need to have a new approach in the future, as Thierry already showed us, in order to include factors and scenarios due to climate change. So it's very important to be able to evaluate the future scenarios, as we saw. So this was actually everything very, very interesting. Our presentation for today are concluded. So if someone would like to take the word and ask a question, given that we are not so many, we could also take the question directly on the microphone. Otherwise, we can, maybe I'll give the floor to Andrea to conclude. If Andrea is still there. Yes. Okay.
Sorry, can I ask?
Yeah.
I have not a question for the speeches, but just to ask you if the presentation will be available for everything, because I found very interesting information in the presentation of the other speakers, and I want to share that information with other colleagues. So, if possible,
Yes. The presentation, all the event, I give this information to everybody. All the event has been recorded, so it will be available on the REMTech website and also in our exhibition room, Asteris exhibition room. Through the exhibition room, you can get in contact. Well, of course, the speaker can get in contact with me directly because we are already in contact, but all the audience can get in contact with me through our conference room. There is a specific function to get in contact with us. So I can give you the contact with the speakers if you are interested. There is also a chat, so everybody should, of the conference, of the whole event, REMTech Expo 2020. So we should be all registered in this chat, and this is another way to get in contact with each other. But to everybody, to the whole audience, I would like to say that you can contact me, and so that I can get you in contact with the speakers if you want to later on discuss some specific topics or to have the presentation. I kindly ask to the speakers if they can share the presentation with me, that maybe I might be able to upload it in our conference room. So yeah, they will be available.
Thank you very much.
Yeah,
Michela?
Margareta?
Yes, hi, I'm Margareta.
Hello.
Hi, everybody, and thank you very much for these very interesting and insightful presentations. I'm Margareta Brey from CMCC. I'm actually the coordinator of the Adriatic project, where Serbia is one of our most inspiring partners, as you have seen by all these things they already have achieved. Nevertheless, I would like to ask the experts from the Asteris project whether how they see the measures undertaken and the attempts Serbia is doing for somehow tackling the problem of salt intrusion they have regarding, for the time being, the pine wood, but in the future also further urban areas.
Okay, so maybe Barbara or Simone would like to answer.
Well, well, me neither. I mean, I couldn't really hear very clearly what Margareta was asking. Well, I think it's the microphone. It's not you. But when I understand, well, the question is about how we envisage, and we can now, at the point where we are designing actions for prevention, right? Was that the question, or did I understand well?
Yes, actually, this was the question. Thank you.
Okay, so let me first say, I mean, it's not for not answering the question, but basically I'm not answering it, because this is going to be really the main point for our next months. And actually we are going, in the first slide that I showed, I've been showing that, yeah, the official deadline for the project was fixed on December 2020, and then we have been impacted by the lockdown time and period, and so we will definitely ask for an extension of the deadline to June 2021. Within this period, we will design and start reasoning the the strategies with the municipalities and everybody conquering and integrating ideas in that respect. Now, the general consideration I wanted to do is based on what, on also another presentation, because I think Michela catched really the main point here is that there is a need for integration. So I can talk about the methods at this time. And to me, it is very important. This clearly emerges from the presentations as a whole today and from the various experiences that integration is going to be fundamental. And this is also going to, when you consider how complex is the system and how different is a different location within the same region, Barbara has been showing us that the dynamics and the way they work for the aquifers in Fano and Ravenna, which are only two case studies, which are the ones considered for our project, are so very much different. So it's going to be tough. We are in a phase where we are basically designing. We have already done this, the vulnerability, and we are assessing what is the risk in the future. But we are not yet entering we have not yet entered fully the phase where we are discussing what the best measure to prevent future risk would be. So I'm sorry for this long answer to not answering, basically, but this is the status. This is the status of the project. And I think not only integration of ideas within the umbrella of our project, but also confronts and learning from other experience, like the one that Capitani has just showed us.
Thank you, Simone. And this is already a response, as I hope you can hear me now, as integration is actually more important and more difficult to achieve than single spot form measures. Thank you very much. And let's keep in contact, because we too asked for an extension to June 21 for the same reason.
Well, I guess everybody
did, I suppose. Okay, so it would be very interesting to exchange these experiences and eventually also showcase your proposals in our knowledge platform we are building. Thank you.
Yeah, well, sorry for this little tail of the answer, but I have to mention that there is, of course, there are already contexts, and I think this will be a very important.
It's 4 o'clock.
Part when, again, we're dealing with actions. That was my computer saying that it's 4 o'clock.
Your computer is a better chairman than me.
I have a Swiss computer.
Thank you very much to everybody for this exchange of point of view from different projects. If someone else from a different experience in the audience would like to add something, we can have a few minutes. Otherwise, we can conclude. I think it was really, really interesting, and it was a way to, as Simone said, to integrate and that was the aim of this conference, was of course being in the framework of our project, a series project, was a way, of course, to disseminate our project, but the point of view was also, that's why is in this context of Coast Expo, the point of view was to try to integrate our subject, our topics of our project with other experience and with other knowledge in order to integrate all the experience from driving factors to application that already exists, as Cervia gave us as an example, in order to go on and go more inside to this problem of the adaptation strategies. So if there's no one else that would like to add something, I don't know if Andrea would like to say something to conclude this first conference of the Coast, Port and Sea. Probably Andrea is not.
Yes, yes.
Ah, yes, okay.
I mean, Thank you, Michele. Yes, we are at the end. I want to thank all of you. And stay tuned with the next conference, the next meeting of COST and the next days. Thank you very much.
Thank you, everybody. And keep in contact if you like through our conference exhibition area. Bye. Yeah.